Hello. Last time we talked about the phases of the moon and rise, set, and meridian crossing times. And this is a picture. Now, this is just a continuation, you see, of the PowerPoint we talked about last time. We have here showing again for the rise and set times. This is a good thing to look at, this slide. So it's showing you the time based on the sun being far over this way. It shows you the times on the Earth. So if you happen to be standing there at the equator, it's noon for you, and 3 hours later it's 3 p.m., there's 6 p.m., then you're into the night, midnight, so on. And this is a good thing for you to practice. So like if there's a first quarter moon, it's over your head or as high as it gets at 6 p.m., it will have happened to have risen at noon. As high as it gets, you imagine this little arrow being a person, Earth rotating around the moon. You first see the moon when you're here. Earth rotates. When it's here and the sun's setting at 6 p.m., that moon's over your head. Then you see the moon getting lower and lower and lower in the sky until it sets at about midnight. So this is a good thing to practice for exam 4. Now let's take a look at some properties of the moon and some things we notice about the moon for today. Well, you ever notice the moon and it looks really big? Sometimes it looks like it's giant, and sometimes it looks like it's normal size. Well, the reason it looks big sometimes is called it's an illusion. It's called the moon illusion. The moon illusion. And it's just because when it's rising or setting and you're looking at it, there's something in our minds, in our brains, that kind of make us kind of perceive it as extra big if you're looking at things along the horizon. And when it actually gets higher in the sky, it looks normal size. It's actually a little bit, when it looks big, it's actually a little farther away than when it's high above you, which is kind of weird. So a way to make it look normal size, now I don't recommend this, but if what you can do is this. You can look upside down, like between your legs, at the moon when it looks big, and for some reason it looks smaller. But if someone sees you kind of bending over and looking kind of between your legs at the moon, it looks really peculiar. So maybe not do that first. Take the insert of a paper towel roll, look just at the moon when it looks big, and it looks normal. You block off everything else. So I tried the paper towel thing first before you look between your legs. So now, what about the moon's rotation? It turns out we always see the same side of the moon. And the same side of the moon, the side of the moon we always see, is called the near side. We have the near side, the side of the moon we always see, and the side we don't see is called the far side. You've probably heard of the far side before. The reason is this, that the moon undergoes what is known as synchronous rotation. It's good to know. It's one rotation per revolution. So there's a little bit more mass on one side of the moon. So if you look at this picture, you see this little red mark there? That's the side of the moon we always see. And that means it rotates as the moon goes around the Earth. That part of it always is facing towards the Earth. It's kind of like what happens if you glue a weight inside a basketball, like cut open a basketball, glue a weight inside of it and roll the basketball. That weight will always be, when the basketball stops rolling, that weight will be pointed towards, the ground. It'll be closest to the ground. The moon has a little bit more mass in one side of the moon has a little bit more mass than the other, and that side always stays facing towards Earth. So the moon does rotate. You can see that it's actually, the moon does spin, but it spins once for every revolution. So it rotates once per revolution. If it didn't rotate at all, that one side of the moon would always be facing the same star, let's say, and we'd see all the sides of the moon. But because it's one rotation per revolution, and that side is always facing us, well, we only see what is called the near side. The side we don't see is the far side. Now, don't get that confused with the dark side of the moon, where it happens to be dark. Where it happens to be night on the moon, it's called the dark side. Where it happens to be day on the moon is called the lit or illuminated side. So that's different than the near side and the far side. The near side is just the side of the moon that's always facing us. Sometimes it's dark and sometimes it's illuminated. And the far side of the moon is the side always facing away from us. And sometimes that's dark, and sometimes that's illuminated, and sometimes it's half and half. So the near side and the far side are not the same thing as the illuminated side and the dark side. So a synchronous rotation, good to know. Moon rotates once per revolution around the Earth. It's called synchronous rotation. Distance of the moon. The best way we've figured out how to the best way we've figured out how far away the moon is by taking a reflector to the moon with the Apollo 11 astronauts. We shine a laser beam at the moon. Now, by the time the laser beam gets to the moon, the laser beam is wide. I mean, it's hundreds and hundreds of miles wide. It's probably wider than actually the whole moon itself. But a little bit of the light hits the reflector and then reflects back to the Earth. And we time that because distance equals rate times time. We can time how long it takes from when we shine the laser at the moon until we get that little flash back. And you can't see that with your eyes. You need probably a very advanced telescope, very large telescope to see it. But it's about 2.6 seconds from when it leaves, the light leaves to come back. So the round trip, 2.6 seconds, which means that one way to the moon it takes 1.3 seconds as far as light travel time. So it's 1.3 light seconds away. That works out to be about 240,000 miles. And we found out the moon is actually getting farther from us each year. We'll talk about that by about an inch and a half, about 4 centimeters per year, an inch and a half. The moon is moving away from the Earth, getting a little farther away each year. So that's the distance of the moon. The best way we use, if you want to write something down, you don't really have to worry about the distance of the moon, 240,000 miles on average, about 239,000 miles. But it's the way we figure it out is laser beam. We use a laser beam and shoot it towards the reflector on the moon. It reflects back, and we can time that. So that's the way. That's the way we get the distance to the moon. What about the size of the moon? This is not, you see what this person's doing here? It's not a good way. Someone ever come to you and say, hey, you see the moon last night? I said, yeah, I saw it. The person said, wow, wasn't it amazing? The moon looked really big. And you said, yeah, well, how big did it look to you? And the person holds their hands like, a couple feet apart and said, the moon looked this big. What do you mean, like 2 feet? What does the moon 2 feet? That's crazy. Well, they're trying to talk about the angular size it looked to them. But it's kind of hard to figure out by looking at the moon how big it is, that the diameter of the moon is. But since we know the distance of the moon, and we know that the angular size of the moon in the sky is about 1/2 degree, we can figure out the diameter of the moon. So we've been able to figure out the diameter of the moon by knowing the distance of the moon and also how big it looks in the sky in angle, which is about 1/2 degree in angle. It's less than a finger's width at arm's length. So it's very, very small in the sky in reality. Hold out your arm if you get a chance and have a finger up, your pointer finger, and see if you can block the moon with a finger, and you can block 2 moons, 2 full moons if you had 2 full moons. So that's a good way to see that. Now, so we know the size of the moon. It's about 2,000 miles in diameter. You don't have to know that, but we're able to figure this out by knowing the distance of the moon. Now, what about this? A couple things to know. Now, a couple times to know, which are pretty important here. It turns out that there are a couple different types of months. Now, without me being able to draw it out, it's going to be really tough to tell you. But a month, remember, or it comes from a month, the period of time it takes the moon to orbit the Earth. It turns out it takes the moon to go 360 degrees around the Earth, 27 days and 7 hours. So write that down. It says 27.3, but write down 27 days and 7 hours. That is called a sidereal month. I'll spell it out for you. S-I-D-E-R-E-A-L. Again, S-I-D-E-A-R-E-A-L. Sidereal, which month, M-O-N-T-H. A sidereal month is the period of time it takes the moon to orbit the Earth with respect to something very far away, like a star. So a sidereal month, know this, is like a star month, how long it takes the moon to go around the Earth and comparing it to a distant star. That's 27 days, 7 hours. I'll say it again. A sidereal month, the period of time it takes the moon to orbit the Earth with respect to something very far away, the stars, is 27 days, 7 hours. Write that down. Now, that is really a true month. The moon goes around the Earth 360 degrees, and that is a true month. We don't use that for our calendar, though. Now, if you want to know how long it takes from like new moon to new moon, that's a little longer. The problem is this: as the moon goes around the Earth, or actually as the moon goes around the Earth goes around the sun. So about 30 days or so later, the problem is this: the sun has appeared to drift in the sky a little bit. So in order from new moon to new moon, that's 29 days and 12 hours. Write that down. 29 days and 12 hours is called the solar month. The solar month, and you know what? Actually, I want you to call it the synodic month. You can call it the solar month or synodic. SOLAR or SYNODIC. You can call it the synodic month. It is a solar month. SYNODIC. It's the period of time it takes the moon to orbit the Earth with respect to the sun. So it's also called like a solar month. And that is the cycle of the phases. So if I were to ask you how long does it take from new moon to the next new moon, it's the synodic month, 29 days, 12 hours. If I were to ask you how long it takes from full moon to full moon, it's the same thing, right? It's the period for each phase, from one phase to the exact same phase, 29 days, 12 hours. From first quarter moon to first quarter moon, 29 days, 12 hours. From last quarter moon to last quarter moon, 29 days, 12 hours. See how that works? From a 3-day old crescent to the next 3-day old crescent, 29 days, 12 hours, the synodic month. That's a good number to know. 29 days, 12 hours. All right. Now, oh boy, don't write this down. Full moon names. And there's some good names here. I mean, a lot of this is good stuff. But it's just this. I never have anybody write this whole thing down. You don't have to know it. But you've heard of moon names like look over. Let me see. The harvest moon, September, the full harvest moon. So every time there's a full moon, every month. Every month there's going to be a full moon, except for possibly February. There may not be a full moon in February because our February only has 28 or 29 days. And remember, to have a full moon, you need to have a period of like 29 and a half days at least. So if you have a month that's longer than 29 and a half days, you're going to have a full moon sometime in that month. And they have names. Most of these are Native American names. So you get some really good names like the full wolf moon in January. I'm not going to ask you any of these. Now, however, the harvest moon, I might ask this. There's even a reading in the tidbits about this for exam 4. The harvest moon is always the full moon closest to the autumnal equinox, with September 21st or so. So that's good to know. There's a good tip. Just read that tidbits about the harvest moon. So that would be the only one I have you responsible for. And again, harvest moon, September, that's when there's harvest going on. So that's how these get their names. But you don't have to worry about all these. It's kind of interesting. Every month has the full moon in every month has a name. I'm not going to even ask you that. But if you're bored, I don't know. I'm sure during this time, a lot of people are bored a lot of time. You can come back and look at this. There are a lot of interesting things, but I'm not going to test you on it. Except the harvest moon. Read that chapter in the tidbits. Now, here's something you should read about also in the tidbits. Something called the blue moon. Since full moons are every 29 and a half days, and if one full moon happens right on the first of a month, which is rare, I mean, it only happens like 1 out of 30 months or so, it means that there would be a full moon right at the very end of the month, on like the 31st. If a month has a 31st, there could be 2 full moons in that month. So, February there can't be a blue moon. The blue moon, it's the second of 2 full moons in a calendar month. It happens about every 2.7 years, 2.5 years, something like that. Read that chat. It's kind of good to know. So let's see one coming up. 2020 on Halloween. Look at that. So that means on October 1st, there's going to be a full moon. And then on Halloween coming up, and hopefully we're let out by then to go trick-or-treating. If it's clear, you can go to like dark neighborhoods and have it lit up because there's going to be a blue moon. It's going to be that second full moon. So the next one coming up is October 31st. And we're going to have a nice full moon then. It's going to be called a blue moon. Now, it's not going to look blue. Why it's called a blue moon, we're still not sure. Sometimes the moon looks a little bluer than others because of the atmosphere, but it's not because it's the second full moon in the calendar month. That doesn't make any sense. So it's called a blue moon, and they say, hey, if something happens once in a blue moon, it just means it's rare. Because a blue moon, the second, if a month with 2 full moons, it's pretty rare, every 2.7 years. So the next one is this year, October 31st. Now, okay, Easter Sunday. I'd like you to know the definition of Easter Sunday as far as what they pick as far as when the Sunday is going to be. Easter Sunday is defined as the first Sunday following the first full moon after the vernal equinox. Now, just, a couple of weeks ago, we had the vernal equinox. And our Easter's coming up. Well, actually, by the time you see this PowerPoint, I think our Easter will have passed. I don't know. It depends on when you see this lecture. But what is it? The 12th? It's a week from today. While I'm making this, I'm doing this on the, what is today? The 5th. So I think the 12th this year. The 12th is Easter. So during Easter, the Easter bunny, Easter peeps, right? I had to get a picture of peeps here. A whole, I don't know what a bunch of peeps is called. Is that like a gaggle? Not a herd. It's like chicks. A herd of chicks. Maggie, what's a herd of chicks called? I guess it's not called a herd. Is it like a cluck? A clutch? Oh, a clutch. A clutch, not a cluck. A cluck. A cluck of peeps. Look at this cluck of peeps. But look, so the first Sunday following the first full moon after the vernal equinox. So what you have to do to figure out when Easter Sunday is going to be, you have to figure out when the vernal equinox is. It's going to be like March 20th through 21st. And then you have to figure out when the full moon after that is going to be, all right, the next full moon after that date. And then you have to go to the Sunday after that to figure out Easter Sunday. Now, look at this, if you want to. Shows asteroid impacts on the moon. Now, because of these, you notice this, that there are asteroids, a lot on this side, and not on this side, and really not many here from the period of, 2005 to 2008. The reason is that this side of the moon is the side sweeping up through space. The moon's always facing us, this side, the near side. That's the near side. Well, if the moon's kind of always moving through space this way, this side's going to get hit more. Kind of like when you're driving in the rain, driving forward in the rain. Doesn't your front windshield get hit a lot more than your back windshield? Well, this is like this. There's like the front of the moon as it sweeps up through space, sweeps through space. There's the back. And the reason that there's not as many here, in order to get to here, an asteroid, there's something that would have to come through first. Because what is the moon always facing? This side. Us. So an asteroid would have to kind of avoid Earth to get to here. And it's tough to avoid Earth. So it probably gets maybe burnt up in our atmosphere. So that's why this side is right over here towards the center is not getting many impacts. The close point of the moon, the perigee, look how big it is in size compared to the farthest point of the moon in its orbit. Now remember, the moon gets as close as 221,000 miles. You don't have to know this, and as far as 252,000. So the moon is sometimes. Oh, you ever heard of a supermoon? It's in the news sometimes. All that means is that it's very close to a full moon, and the moon is near the closest point in its orbit around the Earth, perigee. So the moon looks extra big. And that's a supermoon. That's what's called a supermoon. So if you hear that in the news, it means the moon is very close to its closest point in orbit at perigee. So that's all. And at apogee, you see there is quite a difference here. But unless you have 2 full moons next together to compare, sometimes you can't even tell if it looks like really big or really small, if it's high in the sky. So that is it for today. And actually, you know what? I do want to talk about, I don't want to talk about it now. I was going to talk about the mass of the moon. And, my wife, she just figured out something. Because it's not a cluck. It's not a clackle. It's a brood. A bunch of peeps together, or chicks, is called a brood. So this is a brood of peeps right over here. A brood. So thank you, Maggie. All right, so that's it for today. I was going to talk about the mass of the moon and some other things, and I'm not going to talk about that now. I don't know how long has this been going. This has been going. Seems like it's going forever. It's only 20 minutes. Seems like forever, doesn't it? All right, I'm gonna stop this meeting. I'm sorry if this has seemed to have gone on long. This is I guess that's it. All right, and